Hello everyone, this is Dr. E, and for today we're going to be working on problems involving scientific notation. Learning algebra is fundamentals for you to be able to understand higher math subjects or topics and at the same time understand the language of natural science, just like scientific notation. Scientific notation, by definitions, these are numbers occurring in science that are often extremely large, just like the distance from Earth to the Sun, given by that many miles from the Earth, or extremely small, which is, for example, the wavelength of a blue light, which is approximately that small. And if you'll notice that those numbers are numbers with a bunch of zeros, depending on how large or small those numbers are. And scientific notation is a method or a process that we use to make an extremely large number and abbreviate it to make it a more manageable numerical value to operate when we are dealing with math operations. So scientific notations, because of the difficulty of working with many zeros, scientists often express such numbers with exponents using this method. So that is the reason why we need to learn the language of science and mathematics so that we'll be able to understand that numbers that is represented in a manner that we're not so used to is easily understood if we know how to read them and why it's written as such. So this is how we write the scientific notation with the form a times 10 to the n, where a is a number in between 1 and 10, and n is the power that is supposed to be an integer, so it cannot be a fraction, but it's either positive whole number or a negative whole number. So this is the format that we're going to be achieving to convert our standard notations into its scientific notation form. So a number in scientific notation is always written with a decimal point after the first non-zero digit and then multiplied by the appropriate power of 10, which is basically what our formula is telling us. A times 10 to the n. So how are we going to be converting numbers from its standard notation into its scientific notation form? 1, position the decimal point. Step 2, determine the numeral for the exponent. And 3, determine the sign of the exponent. So a very large number will have a positive exponent in a scientific notation, and a very small number will have its negative exponent. So let's have these examples and let's change this into its scientific form. And you will notice that we have a small number and a very big number, and we're going to standardize them by writing it in this form. So let's start with the first one, which is 0.0571. 0.0571, and we know that this is a small number because it's a number that is less than 1, and we're going to change this into a scientific notation by moving the decimal place to our first non-zero real number, which is 5. So we'll have 5.71, and we're going to affix our power of 10 raised to how many times we move our decimal place right here to its first whole real number. And we did it 1, 2, 2 times. And since this is a very small or a small number, and we move our decimal places to the right, it will remain, or it will hold, a negative exponent as our scientific notation. And this is how we perform the conversion of our standard form to its scientific notation using the formula a times 10 to the n, where a should be in between 1 and 10. And this is, or 0 and 10. So 0 and 10 would be our value. I think it's 1, not 0. So in between 1 and 10, or the positive real number, and this is how we're able to formulate our first notation, which is similar to our answer right here, 5.71 times 10 to the negative 2. So let's continue and convert this big number. So comment down below if this is in billion or trillion or million form, but this big number right here, we're going to convert it into its scientific notation by changing this notation into 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 times. So we have 2.14, and we're going to multiply it with the power of 10, and the exponent is determined by how many times you moved your decimal values. 1, 2, 3, 4, 5, 6, 7, 8, 9 times, and we move it towards this direction, so our exponent will remain positive, and we know that this is a big number. That's why our exponent is a positive number. And this is how we answer problem number 2. And for problem number 3, we'll have negative 0.12346. We'll change this number into its scientific form. 1, 2, 3, 4, 5, 6.2 times 10 to the 1, 2, 3, 4, 5, 5 times. And we know that we move from here to here, so that means we have a negative exponent because this is an extremely small number, but it will remain negative because the sign of our standard notation is negative, so our A will remain a negative number. And this is how we answer, or how we convert numbers from its standard form to its scientific form. And in mathematics, if we learn how to do things, we also need to learn how to undo things. And that's what we're going to be doing in these examples, wherein we're going to be converting the numbers from its scientific notation to its standard form. And we're going to be using our board so that we'll be able to understand this better. And if we have 8.7 times 10 to the 5th power, so that means from 8.7, we're going to be moving, since this is a positive number, we are going to make this a big number, and to make it bigger, we'll move our decimal places to the right, 1, 2, 3, 4, 5. 5 times, and see how many dents we have right here. That means we will replace it with 0, so we have 870,000. We can put a comma right here, and we know that 8.7 times 10 to the 5th power is actually 870,000. So that is problem number 1. And problem number 2, we have a negative exponent, so that means 3.28 times 10 to the negative 6. We are going to move 3.28 to the other direction because this is a small number, negative 1, 2, 3, 4, 5, 6. And we stop, and we have 1, 2, 3, 4, 5 zeros. So that means we have 1, 2, 3, 4, 5, 3, 2, 8 as the standard form of this value. So we have an extremely small value right here on its standard form, and we're able to write it correctly because we're using the format or the formula correctly. So now we have negative 9 times 10 to the negative 4. So we have 9 right here, and this is negative, so that means it will become smaller. So 1, 2, 3, 4, and you stop and fill in the gaps with zeros. So we have 0.0009, and don't forget the sign of your original value, which is negative. So that means we have negative 0.0009 as a converted value for this number. And the answer has been interchanged, but you know what I mean. This is our standard form, and we're able to move that, or we are able to answer this because of the formula that we have used from our previous slides. I just switched my numbers for letter B and letter C, but I'm sure you got the point. So let's see if we can manipulate and perform mathematical operations with scientific notations like so. So we have 3 times 10 to the fifth multiplied to 5 times 10 to the negative 2. And we're going to multiply it using this technique. And to multiply these numbers, it's like multiplying algebraic expression. So if we have 3 times 10 to the fifth power multiplied to 5 times 10 to the negative 2, all we need to do is to multiply the numerical coefficient, 3 times 5, and then multiply our powers of 10. And when we multiply our powers of 10 or exponents, we simply add our exponents. So we'll have 10 raised to 5 minus 2. So if we're going to simplify this, 3 times 5 is 15 times 10 to the add 5 and negative 2, and 5 plus negative 2 is simply 5 minus 2 or 3. And now we have 15 times 10 to the 3. However, we still need to convert 15 to its scientific notation because this is not yet in its scientific notation form. And to do that, from 15 point something, we move it here. So that means we'll have 1.5 times 10 to the 1, because this is a positive 15 number. So this one is a positive 1 times 10 to the 3. And that means we're going to simplify it as 1.5 times 10 to the positive 4, because 1 plus 3 is equal to 4. And now we have its scientific form. And if we want to change it into its standard form, we can easily do that, because 1.5 times 10 to the 4 is 1, 2, 3, 4. 1, 2, 3. So we have 15,000 as the product of 3 times 10 to the fifth and 5 times 10 to the negative 2. And this is correct because we applied the law of exponents, and at the same time, we're able to convert our standard notation into its scientific notation form and vice versa. So we have 1.5 times 10 to the 4, check, and 15,000, check, for our answer to this particular problem. So this is how we multiply scientific notations. And how about dividing them similar to this one? So 4.8 times 10 to the 2 and 2.4 times 10 to the fifth power. We're going to be applying the law of exponents still to be able to accomplish our goal. And to do that, we're going to first write our problem, 4.8 times 10 to the 2 all over 2.4 times 10 to the fifth power. That means we're going to be dividing 4.8 and 2.4, set it aside, and we're going to simplify 10 to the 2 and 10 to the 5. And if we are dividing a power of 10 in mathematics, if we added when we multiplied in division, we're going to subtract the exponent. So we'll have 2 minus 5, and 2 minus 5 is equal to negative 3. So that means we have 10 to the negative 3 for our power of 10. Now, let's divide 4.8 and 2.4. And to make it a little bit easier, let's change this into 48 and 24. And by simplifying 48 and 24, it's similar as simplifying 4.8 and 2.4. So that means by factoring, how many 12s do we have in 48? We have 4 12s, so 4 times 12. And how many 24s? We have 2 12s. So that means we can cancel this out, and we are left with 4 over 2, which is equal to 2. So that means this 4.8 divided by 2.4 is actually equal to 2 times this value, and this is now our scientific notation. And if we want to change this into its standard form, negative becomes small number, so 1, 2, 3, so it's going to be 0.002 in its standard form. And this is how we simplify and operate on numbers on scientific notation form, both in dividing them and multiplying them. So we have 2 times 10 to the negative 3, which is the same value that we got from here, and we convert it into its standard notation similar to this one. And that is our lesson on scientific notation. And for you Let's see if you can find the product of 5.71 times 10 to the negative 2 and 2.14 times 10 to the positive 9 and changing it to its scientific notation, to its standard form. Comment it down below and let's see how much you remembered in our lesson in algebra. And speaking of algebra, when we are working with problems similar to this one, this is also how we work out problems in some of your subjects in the sciences, because we know that mathematics is like learning a foreign language. We need to know how to read it, we need to know how to speak it, and in this case, we need to know how to write it. This is Dr. E. Keep practicing on your conversion, and I'm pretty sure that you will do well on this topic. See you again next time.